Hey everybody, it's Mrs. Bianchi. We're looking at number 5, which is a prism, and more specifically, it's a triangular prism. And if we want to get really fancy, we can say that it's a right triangular prism. And why are we calling it that? Because the triangle bases, which I have highlighted in red, they're right triangles. So to find the surface area of this, we do need to find the area of the triangles, and we need to recognize that we have 2 of them. And then we also need to recognize that the lateral sides, in this case, because this is not an equilateral triangle, that means that the 3 rectangles that we would call the lateral sides would not be congruent. So let's press on with finding the area of one of the triangles. And the formula for one of the triangles would be area equals, and I'm going to leave some space, so I'm going to suggest you do the same thing. The formula would be area equals half of the base times the height. Area equals half, and let's figure out the base. Now remember, the base and the height have to be perpendicular to each other, and we talked in class about how if it's a right triangle, that you want to use what we call the legs of the right triangle as the base and the height. So that means we're using this and we're using this, and they both happen to be the same value. So the base is 10 and the height is 10. Now the reason why I left a space here is because we have 2 of them. We have 2 triangles. We have 2 of them. Now, some of you might realize that if I do this, it cancels out. So really, what are you doing? You're finding the base and the height. And if you take these things and put them together, and even consider rotating it, did you know that it would make a square? So when you put the 2 of them together, you might be able to figure out the area in your head of the two shapes together. You can figure out that that forms a square. But that's over the head for some people. So we'll just go back to the idea of finding the area of the 2 triangles. So let's find the area of one of the triangles. Let's finish up this computation. If we take half of 10, that's going to be 5. And if we take this 5 and multiply it by this 10, then that's going to give us 50. But remember, we have 2 of those. Oops, I meant to do it in green. 2 of those. We have 2 of them. So we carry that through in our formula. And we also want to make sure we write down the A each time. All right, so if we finish up, we know the area of one of them is 50, but we have 2. So if we do 2 times 50, that would give us 100 for the area of the 2 triangles. 100 square centimeters. All right, so that covers the triangular bases. Now let's talk about the rectangles. So I'm going to move these out of the way for a moment. And let's start by talking about, how about we talk about this rectangle right here. We have to figure out the dimensions of that. Now earlier we talked about an equilateral triangle. And if you have an equilateral triangle, then all the rectangles would be the same. But that's not going to be true for other types of triangles. In other words, triangles that are not equilateral, such as a right triangle, an obtuse triangle. So let's look at this ramp, you might call it, to this shape. And if we figure out what the dimensions are, this line right here is the same as this line, and they're telling us that that's 14 1/10. So let's write down that this top, in fact, sometimes it's a good idea to label that we're doing, the top. This might be the top of the thing. Base times height. And if we plug in the numbers, we're saying that this number is 14 1/10. And what's perpendicular to it would be the height. So that's this number. See how this line and this line would be perpendicular to each other? So we're multiplying it by 30. All right, let's take out our calculators, and we're going to multiply 30 times 14 1/10. And we get this number, 423. Let's move that out of the way. 423. All right, so that covers the green piece. So let's move that out of the way. In fact, maybe it's a good idea to do this. All right, so now let's talk about this piece right here. The floor of this thing. What are the dimensions of that? So let's call this the bottom. Area equals base times height. It's a rectangle. And let's figure out what's perpendicular to each other that we can use as the base and the height. Now, if you think about what this would look like here, this would be a right angle, even though it doesn't appear to be in the artist rendition of this thing. But this is 10, and this would be 30. So we can use 10 as the base and 30 as the height. And the lights just went off in my classroom. All right, so let's finish up. We can do this in our head. We can do 1 times 3 in our head, which would be 3. And then we just have to remember to add the 1, 2 zeros to that. So the area of that piece on the bottom, this piece right here, would be 300. All right, now we're not done because we haven't covered the piece in the back, this piece right here. Because remember, we have 5 faces total, so this covers 2 of them. This is the 3rd one, this is the 4th one, and now that we're doing the 5th one. All right, so we might call that the back. Good idea to label back. And it's a rectangle, so we'll write down base times height. By the way, here we should probably add that this is square centimeters. And we should probably do that here as well, just to be completely correct. All right, so now let's talk about the back. What are the dimensions? So we have to know what this dimension is, which would be the same as this dimension. They're telling us it's 10. And then we need to know this dimension. Now this dimension, let me use this line here to show you something. This line right here and this line right here would be equal and congruent because they're opposite sides of rectangles. And sometimes when you look at it on a two-dimensional thing, it can confuse you. So if this is 30, that means this is 30 also. So this is a 10 by 30 rectangle. Let's substitute in the numbers. Area equals 10 by 30. So in other words, that's kind of the same thing we had for the other one. It's the same shape, and that makes sense because the legs of the triangles are equal, and that would be 300 square centimeters. All right, now to find the surface area of the entire thing, we have to add up all the faces. So we have 2 of the faces here. This covers the, here and here. So each are 50. We have the piece that we're calling the top, we have the piece that we're calling the bottom, and the piece that we're calling the back. So the only thing left you have to do, add up all the things I have circled in yellow and show the algorithm for that on your piece of paper, and you'll get one of these answer choices. All right, good luck finishing that up.